We have some to product identities that show us if we are adding two trigonometric functions, sines and cosines, or even subtracting. We can write those as a product of sine and cosine functions. Now, these look pretty complicated. I'm going to go ahead and prove one of them for you so you can see where these come from. I'm going to just do this first one here, the sine of x plus the sine of y. First, what we're going to do is we're going to do a little substitution here where we're going to let x equal a sum, alpha plus beta, and we're going to let y equal the difference, alpha minus beta. And this may seem odd that we're doing this at this point, but let me just go through and then you'll see why we do these. They work out nicely and give us these nice identities. So first of all, from these, we actually want to write alpha and beta in terms of x and y. And so we can take these, and if you add these two equations, notice that you'll get x plus y, okay, equals, and then you add these together and you just get 2 alpha. The betas will cancel, so 2 alpha. In other words, alpha can be written as x plus y over 2. So maybe now you're already seeing like why alpha is going to doing this is going to help out get this identity. We could also subtract these two. And if we subtract them, we're going to take x minus y. The alphas will cancel. We get beta minus a negative beta, which is 2 beta. Okay. And then if we divide by 2, we get beta equals x minus y over 2. All right, so now what we can do is we can use the product to sum identity. Let's go ahead and look at that. The product to sum identity for sine times cosine. Sine of alpha times cosine of beta. The identity is that this is 1/2 times sine of alpha plus beta plus sine of alpha minus beta. Well, now I can plug in everything that I know about alpha and beta in relation to x and y. So plugging these in, I have sine of alpha, which is x plus y over 2, times cosine of beta. Beta is x minus y over 2. And that's equal to 1/2 times the sine of alpha plus beta, which is x, and then plus sine of alpha minus beta, which is y. Okay. And if we multiply both sides by 2 to get rid of this 1/2, we get 2 times the sine of x plus y over 2 times the cosine of x minus y over 2 equals sine of x plus sine of y. And that's that first identity that we had here. Okay. So all of these are done in similar ways where we actually look at the product to sum identities for with the cosines and times the cosine times cosine and cosine times sine and so on. And so these are all derived in a similar manner.